Okay guys, the last part of our notes today dealing with secants is with segment lengths of a circle. So we just finished up with angles that was created by secants. Now we're going to talk about segment lengths that are created by two secants. So in this first example, we have our two secants cutting through the circle, and it creates pieces of the segment basically that I call outside of the circle. So W is outside of the circle, the length of this piece. And then we need to look at the length of the whole segment. Okay, so if I want the length of this whole secant, we would add these two pieces together. So that would be x plus y for the whole part. So again, if I want the length of this whole secant, I'm going to add z plus y to get the length of that secant. So the rule to figure out these pieces is you're going to do the outside. So I'm going to put it in words first. So outside times whole secant equals, same thing on the other side, outside times whole secant. So that's it in words. So outside times the whole thing. So outside times the length of the whole secant. Outside times length of the whole secant. So in words, now let's put it together with our variables. So the outside piece is W times the length of the whole secant is x plus y, x plus W. And that's equal to the other secant. The outside is y. The length of the whole secant is z plus y. So that's the rule to find these segments. And we'll do some examples in just a minute. Our next scenario is two secants inside of the circle. And basically this says a times b. So a times b is equal to C times D. So that one's pretty easy. The last scenario, we have a secant and a tangent. So this is our tangent because it touches in one spot. This is our secant, intersects the circle in two places. Okay, so this rule says in words, tangent squared is equal to outside times whole secant. So that's what it says in words. So now let's use the variables that they've given us. So our tangent they've called t. So t squared is equal to outside of the circle times, I need the length of that whole secant, so that would be z plus y. And that's going to be the rule we use for this situation. Okay, so let's apply these. So example 11 says solve for the variable. We're going to round to 2 decimal places. So if you look at example 1, at your 3 cases, this is a tangent and a secant. So it's the last rule I just covered. So you've got to figure out, okay, what part represents the tangent, touches in one place. Okay, so you're going to say tangent squared, so z squared equals outside times the whole secant. So the outside part is 8 times the whole secant. I'm going to add 8 plus 16 to give me 24. So outside times the whole piece gives us 8 times 24. So we have z squared equals, when I multiply that together, I'm going to get 192. Then we're going to take square root of both sides, and because we're talking about the length of this segment, we don't have to worry about the negative. So the square root of 192, if we round to 2 decimal places, is going to be 13 0.86. All right, so for example 2, if you look up at your 3 cases, it's like this first case we talked about. So outside times the whole secant is equal to outside times the whole secant. So let's go ahead and figure out the length of both secants. So I added 6 to 8 to get 14. This side I have a variable, that's okay. You're just going to add y plus 7 to get a length of y plus 7. So we're going to do exactly what it says. Outside piece, so my outside piece is 8 times the whole length is 14 equals outside piece is 7 times the whole thing is y plus 7. And we're going to distribute and solve. So 8 times 14, that's 112, equals 7y plus 49. When we distribute, subtract your 49. So on this side we're going to get 63 equals 7y. You'll divide by 7. So y is 9. And then your last example is the easy one. So we'll call this A. Let's don't do that. So basically you need to look at your secant and you're going to multiply each piece by each other. So 6.5 times m is equal to 7 times 3. So I'll write it all out so you'll know what we multiply. So 6.5 m is equal to 21. We'll divide. And when you do, you're going to get 3.23 when we divide that. And that's what it looks like when you apply those 3 different rules for segment lengths of a circle.